question 8. So, reasonably straightforward, I think. Remember, anything inside the function affects the x values and does the opposite to what it says on the tin. So rather than doubling the x coordinates, this halves the x coordinates. So we're going to cross the axes still at 0, 0, but instead of 6, 0, it's going to be 3, 0, and the minimum, instead of being 3 minus 1, will be 3 over 2 minus 1, as over here. Now for part B, we've got the change outside the bracket. This affects the y coordinates, but does exactly as you would expect. So this is just changing the sign of the y coordinates. So that has no bearing on where it crosses the x-axis, because obviously y equals 0, but it does change the minimum from being 3 minus 1 to being a maximum at 3 plus 1. So it's basically a reflection in the x-axis. Now for part C, we're inside the bracket, so that's affecting the x values, and it's doing the opposite to what we'd expect. So it's actually doing a minus p to all the x values. Now we're told that p is between 0 and 3, so think about this curve moving to the left, but by less than 3, so the minimum is still going to be in this third quadrant. Where this crossing of the x-axis is going to be at 0 minus p, and this crossing is going at 0. Is that 0 minus p or minus? Yeah, 0 minus p. So minus p 0, I should say. Excuse me. And this one is now crossing at 6 minus p, so the coordinate 6 minus p 0. So where it's actually crossing the x-axis is at minus p, 6 minus p, and the minimum is going to be at 3 minus p minus 1.